Okay, another video for about rates of change. What do we have here? We have a 1.8, sorry, meters tall man is moving away from a street light at a rate of 0.4 meters per second. So this man here, AB, is moving away from a street lamp. This is the lamp, okay, uh, uh, away by a rate of 0.4 meters per second, right? If the light is 20 meters vertical, this is given, the light is 20 meters vertical, above the ground, how fast is the tip of the shadow moving? This tip of the shadow, which is S, the tip of the shadow, how fast it will move if the man is moving in a speed of 0.4 meters per second when the man is 10 meter away from the street light. Man is 10 meter away. Uh, First, first, let us denote by m. This m here is the distance. This m here over here is what? Is the distance from the man to the street light, and by s is the distance from the tip of the shadow to the street uh, light, right? Now, what do we have in the figure here? This is very simple, very easy. We have two triangles, ABS, triangle ABS, and triangle CDS, right? And they both are similar triangles. Why? Because we have here 90 degrees, right? And 90 degrees, okay? The man is perpendicular to the ground, and the light is also perpendicular. The street light is perpendicular to the ground. What do we have here? We have S is in common angle. Two angles equal. They are similar, so we can say that SA over SC is equal to AB over CD. That's great. What is SA? SA is simply it's all SC minus AC. So we can substitute, instead of SA, it's all SC, which is S, minus AC, which is M, right? Over SC, which is also S, is equal to AB. We have it 1.8 meters, and CD we have it 20 meters. That's great. Let us find S in terms of, because he wants to find how fast the shadow. Let me find a formula containing S. 1.8 S equal 20 S minus 20 M. All right, taking S to the same side, so 20 S minus 1.8 S is equal to 20 M, right? This, what we did here is we took the 1.8 to that side of 20 S, and we took the minus 20 M to the other side. It will be 20 M, right? Let me find S in terms of how much is 20 S minus 1.8 S. It is simply 20 minus 1.8 is 18, sorry, 0.2. S is equal to 20 M. So what is S equals to? S equals, let me start here, S will be equal to 20 M divided by 18.2, right? 20 M divided by 18.2. Let me see how much is that value. 20 divided by 18.2, it will be equal to 1.098. 1.098, right? So it will be S equal 1.098 M. That's nice. Let us find the derivative of S now. What is the S dt? The S, we derive this side with respect to dt, and that side, which is 1.098 constant, we take it outside, the M over dt. That's good. What do we have now? We have now that the S to dt is equal to 1.098 times the M dt. What is the M dt? The M dt, it's given. He said from the beginning that the man is speeding M away from, or 10 meters away, but he's speeding at a speed, he's going far away from the street light in a speed of 0.4 meters per second. So we multiply this by 0.4 meters per second, right? So the answer will be let me multiply the answer we obtained, or oh, I deleted it, 1.98, right? 1.098, sorry, 1.098 times 0.4, right, meters per second. So I got what? 0.439. So approximately it is approximately 0.44 meters per second. That's it. That's it. We have the value dm to dt, just need the value ds to dt. And that's all about this exercise. We have to be careful here for something. He gave me 10m, but we didn't use it. We did not use it. We just took m at any distance because the rate of change will not change, right? So we have the rate of change. We don't need the 10 meters here. This is a problem. Let's see another problem. If we don't have time, I will continue this problem in the other video. So let me begin with this video. Okay. Another problem says what? Okay, water is being poured into a hemispherical tank of radius 12. So what do we have? We have a hemisphere, right? A hemisphere, it's a half sphere, right? Hemispherical tank. And let me, okay. Let me take this as hemispherical tank, and he said a tank has a radius of 12 inch, right? Water is poured in 12 inches, right? At a rate of 5 inches cube per second. The rate is 5 inches cube per second. The rate of what? Of pouring water. Water is poured here at this rate. Okay, after some time, right? The level of water in the tank will be, let's say this. Let's say this is the level of water in the tank, right? After some time. That's great. Part A, let's start with part A. Part A says, given that the volume of the water contained in the shaded segment, right, down the bottom of the hemisphere, is V equal, it's given, V equal pi h square multiplied with 36 minus h divided by 3. So pi over 3h square into 36 minus h. What is h? It's the height of water in the bottom of the tank. This is h. Find the rate at which the level of water is rising when it is 2 inches deep. Means when h equal 2 inches, what is the rate? What is the rate of water, right? 2 inches. What is the rate of water rising? What is the rate of water rising in the bottom of the hemisphere? This is part A. Let me start with part A, and I will continue the rest if we have time, because we still have just a minute and a half. Okay. First, let me try to get another easier shape of this volume. So let me multiply this number times this number. 36 divided by 3, it's 12 pi h square minus pi h cube divided by 3. This is the volume of the water in the hemisphere, right? Let's find the derivative of this. Okay, we need to maximize. This means we need to find the derivative of this according to height, right? What is the derivative according to height as a variable? It's 2 times 12 is 24 h, 24 pi, I mean, h, right? Minus 3 times 1 over 3, it's 1 pi h square. That's nice. We can take pi h as common. We're left up with 24 minus h. That's great. So what do we know about dv over dh, right? dv over dh, what do you know about it? Or dv over dt, we can start with dv to dt, right? To dt. It's simple. dv over, this is chain formula if you remember, times dh, right? dt. That's great. So what we have to find is dh to dt, because he's asking about the height of rising the height of water in the bottom. All right, I think so.